Hello students, welcome to my class. In this video we are going to be discussing about stationary waves and stretched string problems. Let us see the first question. The first question says the length of the sonometer wire is given as 90 cm and the stationary wave setup in the wire is represented by y equal to 6 sin pi x by 30 cos 250 t is given, where x and y are in centimeters is given and t is given in seconds is given. The number of loops and amplitude of the superimposing wave they are asking. So here stationary wave equation is given, students. Y equals to 6 into sin, that is pi x by 30 into, you can cos, here it is given as 250 t is given. Now here general equation of the wave or stationary wave, if you are taking 2a into sin kx into, here you can write it as cos omega t. So this is a general stationary wave equation. When you are comparing this one, instead of 2a, here it will be 6 will be there instead of amplitude. So here you can write as 2a equal to 6. That's nothing but amplitude will be getting as 3 centimeter you are getting. So this is the first one what they are asking. Let us see the next one. Here instead of k here it will be, it's a pi x by 30 will be there. So here k is the propagation constant will be calling. Here you can get it as 2 pi by lambda, which is nothing but here it is given as pi by 30 is given, and here pi gets cancelled, lambda equals will be getting a 60 centimeter you are getting. We need to calculate the number of the loops. So to calculate the number of the loops, here L equals to, you can take as, suppose here number of loops if you want to calculate in the given length of the wire, in the sense here you can take, here we will be having like and so on. Here we will be having the p loops will be having means in this wavelength, and here you will be getting this is the node point and this is the node point, and here p segments if it will be there, in the sense L equals the distance between the 2 points will be getting as wavelength. This is the lambda by 2 and p segments will be there, so you can take as p into lambda by 2 you can take. So this is a general formula we are going to be using for getting the number of segments or number of loops. L equals to p lambda by 2 if you are taking, and with this if you want to calculate the number of loops, in the sense here number of loops, so here p segments will be there, this is on p segments you can take number of loops, which is nothing but p you can take, students. P equals to, here you can take as 2l by lambda you can take, and 2 into, here it's given as 90 centimeter is the length of the sonometer wire. By wavelength you got it as 60 centimeter, and here 230 times and here 33 times you can take. So number of loops will be getting as 3 will be getting. So amplitude is 3, and here number of loops also will be 3 will be getting. Let us see the next question. The next question says the equation y equals to 5 sin pi x by 25 into cos 450 t represents a stationary wave setup in a vibrating sonometer wire, where x, y are in centimeters and t is given in seconds. The distance of second and third nodes from one end of the wire they are asking. So let us see the equation of stationary wave is given as y equals to 5 sin, it is pi x by 15 it's given, into you will be getting as cos 450 t is given, and you just write the general equation of stationary wave is y equals to 2a into sin kx into, you can write it as cos omega t you can take. So instead of k, here you will be getting as, this is pi x by 15 will be there, this one you can take. K is the propagation constant, 2 pi by lambda, which is nothing but pi by 15 it's given, pi gets cancelled, and here wavelength you are getting as, this is 25 it's given, and here wavelength lambda equals to 25 into 2, here we will be getting just cross multiply this one, and here it is nothing but 50 centimeter is the wavelength we will be getting. Now the distance of the second and third nodes from the one end of the wire they are asking. So here nodes are nothing but, here you can take, nodes are nothing but where amplitude of the wave will be 0. Amplitude is 0 you are taking. So amplitude you are getting as 0 for sine function. Here it's given as sine. This is pi x by 25. So this is here you can take, which you can make it as 0 you can take. That means sine function is an integral multiple of here if you are taking. It's nothing but sine value where you are getting 0 in the sense. Here you can get it as 0, 180, like 2 pi, 3 pi, like and so on will be getting. And here you can take as this is nothing but for n integral multiples you are taking means n pi you can take. Where n equals to here you can take as like 0, 1, 2, 3 and so on like that you just take. So n equal to 0, 1, 2, 3 and so on like that you are taking means here you can take this x values where you are getting in the sense. X values when you are putting here in this equation, n values when you are putting 0, 1, 2, 3 and x is the distance of node points will be getting. X equal to will be getting as 0, lambda by 2, lambda, 3 lambda by 2 and so on like that will be getting. So this is the first node point and this is the second node point and this will be the third node point. So here they are asking a first node and the second node, third node point and like fourth node point like and so on you can take. They are asking here. So the second node point and as well as third node point they are asking. Second node in the sense here will be getting as lambda by 2. Lambda by 2 is nothing but lambda we got it already 50 by 2 which is nothing but 25 centimeter. And the next third node if they're asking in the sense that is lambda which is nothing but 50 centimeters you are getting. So here the answer is 25 and as well as 50 centimeter. Let us see the next question. The vibrations of a string fixed at both the ends are represented by y equal to 16 sine pi x by 15 cos 96 pi t, where x and y are in centimeters and t is in seconds is given. Then the phase difference between x equal to 13 and x equal to 16 centimeter in the radian they are asking. Let us write the equation of the stationary wave, students. Here y equal to 16 into sine, it's a pi x by 15 into you will be getting as cos 96 pi t, and you can rewrite this one in the general form of the stationary wave. Y equal to 2a sine kx into you can get it as cos omega t can take. So instead of k here it will be pi x by 15 will be there. K equals to you can write it as 2 pi by lambda formula. This is pi by 15 you can take. This pi gets cancelled. When you are cross multiplying this one, lambda equals will be getting as 30 centimeters you are getting. So lambda is 30 centimeters you are getting. For node points here you can write as, for nodes here you can write as sine, this is pi x by 15 you can make it as 0, and here pi x by 15 here sine function will be 0 at 0, pi, 2 pi, 3 pi and so on will be getting. That means here x values when you are calculating node points in the sense, here initially will be getting a 0 and this is 15, and here you just take this side, students. Here this is pi x by 15 which will be equal to pi when you are taking. Pi gets cancelled, x equal to will be getting as 15, and the next case pi x by 15 which will be equal to 2 pi when you are substituting. Pi gets cancelled and here x will be getting as 30, like and so on you can take 15, and here it will be 30, next will be 45 and so on will be getting. But wavelength we got it as 30 centimeter means here is going to be producing the segments will be like this, and here you can take and this the total wavelength is given as 30 centimeters we are getting, and this will be a node point and this is the node point, and here this is one more node point it's given. So here it is nothing but here lambda by 2, in the sense here we'll be getting this is at 15 centimeter, and here they are asking in between x equal to 13 centimeter, and here between the points here this is at 13 centimeter, and the next one they will be asking us at 16 centimeters. So phase difference is nothing but here we'll be getting as phase difference is nothing but here we'll be getting as it's nothing but n pi will be getting n into pi. So here when you are talking here x equal to 13 and x equal to 16 centimeters, in the sense here how many nodes will be present, node points will be present, in the sense only one node point will be present. Then you have to put the n value will be 1. N when you are putting 1, in the sense here delta phi is the phase difference will be getting as pi will be getting. Or else you can take, students, here in stationary wave equation. So here the particles which are in the one segments, they will be in phase will be getting, and the particles here you are taking, the other particles here you are taking. And let us take here an example here. This is an A point, and this is a B point, and this is the C point and D point when you are taking. And here A and B particles, they will be in the same phase will be getting, and whenever you are taking the B and C particles, they will be in opposite phase will be getting in stationary waves. And C and D particle will be in the same phase, A and B particle will be in the same phase in stationary waves, but B particle and C particle, A particle and D particle will be in opposite phase, so that phase difference will be getting as pi will be getting. Let us see the next question, students. 3 consecutive resonant frequencies of stretched string fixed at both ends are 60 Hz, 90 Hz and 120 Hz is given. Then the given frequencies are in the ratios they are asking. Means here it's a elimination method. Given frequencies are in the ratio 1 is to first, third and second one, like that it's given. And here the next thing is here it is given as given frequencies are in the ratio second, third and fourth overtones, and these are the harmonics is given, and third one is fundamental frequency is given as 30 Hz is given, like that they are given. And here to calculate the fundamental frequency, you can take difference in the frequencies, difference in frequencies, give the fundamental frequency, give the fundamental frequency, that's nothing but here you can take as 90 minus 60 you can take, students, which is nothing but 30 Hz you will be getting. So what are the frequencies you are getting in this sense? Here frequencies you are getting as 30 Hz, next is 60 Hz, next here will be getting as 90 Hz, and here like 120 Hz, like that, and like that will be getting. So means here it should be divided with the any factor. So here you will be getting as 31 times, 32 times, 33 times, 34 times when you are talking. So here given frequencies are first, third and fifth harmonic is given, it's not the correct answer, so you can eliminate. And the given frequencies are second, third, fourth overtone they are given. It is also, this is a fundamental frequency when you are calculating, or first harmonic, and this will be the first overtone will be calling, not the second overtone. This will be the first overtone, and this is the second overtone, third overtone, like that we can call. And the third option is given as fundamental frequency is given as 30 Hz is given. So here f equal to 30 Hz is the fundamental frequency, which is the correct answer. Let us see the next question, student. The equation of the standing wave produced on a string fixed at both the ends is given as y equal to 0.4 sin pi x by 10 into cos 600 pi t, where y is measured in centimeter. What could be the smallest length of the string they are asking? So here the equation of stationary wave we can take, students, 0.4 sin, this is pi x by 15, pi x by 10 into will be getting as cos 600 pi t is given. We just write the general equation y equals to 2a sine kx into cos omega t. You can take here instead of k, here it will be pi x by 10 will be there. So k propagation constant, k equals to pi by lambda, which is nothing but here you can take as pi by 10. You can take pi gets cancelled, cross multiply this one, lambda equals will be getting as 20 centimeters you are getting. So to calculate the what could be the smallest length of the string, to calculate here in the given length of the string L equals to how many loops we can able to produce, in the sense p into lambda by 2 you can take. So for smallest length, for L minimum we can take p should be a minimum value, that is here you can take as p equal to 1 you can take, students. When you are taking here L minimum, which is nothing but instead of p you can substitute as 1 into lambda by 2 you can take. Lambda which you calculated already 20 centimeter, so here you can take as 20 by 2, which is nothing but 10 centimeter you can take. So this is the correct answer. Let us see the next question, students. Standing waves are produced in 10-meter long stretched string fixed at both ends. If the string vibrates in 5 segments and wave velocity is given as 20 meters per second, the frequency is there asking. So here this is a fundamental frequency formula, and a stretched string formula will be, it's a V by 2L will be getting, students. So V by 2L, 1 by 2L into V is nothing but you can take as root over T by mu. This is for one segment, you will be getting as fundamental frequency, students. Therefore for P segments when you are producing, here you can take as, so this is for one segment or loop you can take. And P segments when you are producing, here you can take as P into V by 2L you can take. Here the frequency they are asking, and here velocity is given, and here 5 segments you are producing, and here length is given as 10 meters. You just substitute here, students. P in the sense here you can take as 5, velocity will be 20 by 2 into length you can take as 10 you can take, and here 10 to is 20, 20 gets cancelled, here will be getting as 5 edge will be getting. Let us see the next question, students. Length of the string tied between the two rigid supports of 40 cm is given. Maximum length of the stationary wave produced on it is there asking. So here a length of the string is fixed between the two rigid supports is given, means here L equals to you can take as, this is the total length is given, students. Here maximum wavelength will be getting as between the two node points will be getting. So here this length value is given as lambda by 2, which is nothing but 40 centimeters given. So here you have to substitute, students. L equals to lambda by 2. L is given as 40 centimeter, which will be equal to lambda by 2 you can take. It's nothing but lambda equals to 40 into 2 you can take, which is nothing but will be getting as 80 centimeters will be getting. So let us see the next question, students. Calculate the frequency of the second harmonic. It's given as second harmonic is given, and string of length is given as 0.5 meter, and its mass is given as 2 into 10 power minus 4 kg when stretched with the tension of 20 newtons they are given. Now here we need to calculate the frequency. Frequency for second harmonic you can write it as, that's nothing but F2. It's nothing but 2V by 2L you can take. 2V by 2L is nothing but here you can take as V by L. V is nothing but here you can take as root over T by mu you can take. For two segments here you can take as 2V by 2L. For P segments you can take as PV by 2L you can take. So F2, which is nothing but here we'll be getting as 1 by length. The length is given as 0.5 meter into e-conductor's tensional force is given as 20 Newton by mu, in the sense linear mass density. Linear mass density here it's given as mass per unit length, and here mass is given as 2 into 10 power minus 4 kg by length is given as 0.5 meter, and here you can rewrite this one 0.5 you can take as 1 by 2. When it goes to the numerator, 2 into 2 will be getting as 4 into 10 power minus 4 you can take, and 4 into 10 power minus 4, and here you can get it as 450, and here you can take as F2, which is nothing but 1 by 0.5 you can take as it's 0.5 you can take as 1 by 2. You can bring it to the numerator 2 into, so this is 5 into 10 power 4 you can take, which is nothing but here you can take as 2 into 10 power 4 you can take outside, 2 into 10 square into root 5 you can take, 200 into root 5. So root 5 nearly will be getting as 2.25 something will be getting. It's an approximate value you can take, 200 into 2.5 you can take. So which is close to nearly will be getting as 447.2 H will be getting. So this is the correct answer. Let us see the next question, students. Here a wire of length is given as 1 meter and mass is given as 20 gram, and here it is stretched with a force of 800 newtons. Find the fundamental frequency and also find the frequencies of the first two overtones they are asking. First two overtones they are asking, students. First you need to calculate the fundamental frequency. Fundamental frequency formula will be getting as 1 by 2L into you can take as root over T by mu you can take. So 1 by 2 into L is given as 1 meter it's given, and here root over T by mu. Tension is given as here 800 newtons by linear mass density. So it's a mass per unit length. Mass is given as 20 grams is given. 20 grams you have to convert by length will be 1 meter, and here 40 times here, and here you can get it as 1 by 2 into you can take as here 40 into 10 power 3 you can take, and it's 4 into 10 power 4 will be getting, which is nothing but we just bring into the outside 2 into you can take as 10 power 2. So here the fundamental frequency will be getting as 100 Hz will be getting, and fundamental frequency is 100, and also find the frequencies of the first two overtones they are asking. So this is a fundamental frequency, and the next one will be getting is this is F1. Suppose you are taking F2 equals to twice of F1, which is nothing but 200 H, and F3, which is nothing but 3 times of the F1 will be getting, it is 300 H. And this is a fundamental frequency or first harmonic will be calling, and this is second harmonic or first overtone will be calling, and this will be the third harmonic or second overtone will be calling. So frequency of the first two overtone 100 H, 200 H and 300 H. Let us see the next question, students. The third overtone produced by the vibrating string of length is given as 2 meter. Length is given as 2 meter, long is given as 1200 H. What is the velocity of the propagation of the wave they are asking? So here they have given as already third overtone is given. For third overtone, or else you can take as third overtone, or will be calling as, or it is the fourth harmonic will be calling, students. For n harmonic functions, the frequency here it's nothing but f equal to, here you can write it as pv by you can take as 2l you can take. For 4 harmonics, in the sense 4 segments it's going to be producing, so you can take as pv by 2l you can take. So p in the sense here you can take as 4 you can take, and so v you can take as, when you don't know we need to calculate by 2 into l value is given as 2 meter it's given, and this frequency already it's given 1200 Hz is given. So here 2 2s are 4, and here this 4 gets cancelled, so f4 is nothing but you can take as v. So here frequency already it's given as 1200 it's given, so here therefore velocity which will be equal to, here will be getting as 1200 meter per second will be getting. Let us see the next question, students. The fundamental frequency of the string stretched with the weight is given as 4 kg. It is 256 Hz is given. The weight required to produce its octave is they're asking. So here instead of weight is given as 4 kg, students, here we need to take as 4 kg weight we need to consider for 256 Hz. The weight required to produce the octave they're asking. So here octave doesn't mean here final frequency, which will be equivalent to the twice of its initial frequency you can take. And here you know the frequency formula, f equals to 1 by 2L into you can take as root over T by mu. So here they're asking the relation between frequency and as well as weight they're asking. Here weight is nothing but tension force you can take, which I am going to be relating as F is directly proportional to root T you can take. And here they're asking second weight they're asking, which is nothing but here you can take as T is directly proportional to you can take as F square by squaring on both sides. Now you can take as T2 by T1, which will be equal to you can take as F2 square by F1 square you can take. F2 we got it as already twice of octave doesn't mean twice. So it's a 4 F1 square by here you can take as F1 square, F1 square, F1 square gets cancelled. So T2 which will be equal to you can take as 4 times of T1 you can take 4 into T1. T1 you'll be getting as it's a 4 kg weight it's given 4 kg weight. It's nothing but 16 kg weight is the correct answer. Let us see the next question, students. A guitar string is 90 cm long it's given and has a fundamental frequency 124 Hz. Where should it be pressed to produce the fundamental frequency 186 Hz they're asking. So here you can take, students, here a guitar string it's given and here where should it be pressed to produce the fundamental frequency of 186 Hz. So here tension in the string you can take as constant you can take, students, and here F equals you will be taken as 1 by 2L into root over T by mu. And here tension if you are taken as constant and density of the wire also it will be constant, then F is inversely proportional to length you can take. And here we need to calculate the final length value. Here L2 by L1 which will be equal to you can take as F1 by F2 you can take. And it's nothing but here you can take as L2 which will be equal to F1 by F2 into you can take as L1 you can take. And F1 is given as 124 Hz by here you can take as 186 into you can take as L1 is 90 cm. And here you can take this is 4 3s are 4 1s are you can take 4 4s are 16 26. So here it's not going, like here you can take, or else 2 table you can take, students, and 2 6s are 2 twice, 2 9s are 2 3s are will be getting, and here 31 93 here if you are taking 3, and again here you can take as 31 times, and here it will be here this is 62 times. (93) 62 by 93, and here you can take as 30 if you are taking 31 31 62 by 93 into 90. Altogether here you can take as 62 into 90 by here you can take as 93 you can take, students, and this value will be getting as nearly 60 centimeter you are getting. L2 you are getting as 60 centimeter you are getting. Let us see the next question. A string, a stitched string of length is given as 1 meter, and here its mass is given as 5 into 10 power minus 4 kg, is having the tension is 20 newtons. If it is plucked at 25 centimeter from one end, and what will be its frequency they are asking. And here initially tensional force is given, students. Here suppose here when you are plucking the string, 1 meter length is given. This is whole, here you can take as 1 meter length you can take, students. So here at that here if you are plucking at 25 centimeter distance, at the point of plucking you will be getting as an antinode, it will be forming. Here if you are taking an antinode, and here next again here it's going to be forming one node point like this. So be remember, at the point of plucking you will be getting as antinode. Antinode when it is forming, this is an antinode, and the next node point will be getting, and this is an antinode will be getting. So here you will be getting as two segments will be getting. Here total length is given as 1 meter, and here you are plucking at 25 centimeter. So that doesn't mean here we are going to be producing the two segments. So total number of loops will be getting as two segments or two loops we are going to be producing. So here we need to calculate the frequency. The value will be getting as for two loops 2 by 2L into, you can take as root over T by mu, you can take 2 gets cancelled. So here length is given as 1 meter, which is nothing but tensional force is given as 20, and here it's a linear mass density in the sense here you can take as 5 into 10 power minus 4 mass per unit length. The length is given as 1 meter, and 4 times you can take, it's nothing but 4 into 10 power 4 you can take in numerator. That means here frequency will be getting as, when you are taking outside 2 into 10 power 2, which is nothing but 200 Hz will be getting. This is the correct answer. Let us see the next question, students. Here a second harmonic has been generated for a string of length is given as L, stretched between the two rigid supports. Here two rigid supports it's given, students. These are two rigid supports, and this length of the wire is given as L is given. The point where it will be plucked and touched they are asking. And here it's going to be producing the second harmonic, students. Second harmonic is nothing but, so here it's going to be producing the two loops like this. So here a second harmonic is nothing but second harmonic, which will be equivalent to the number of segments or number of loops. So here you can take as two loops you can take, and here where it should be plucked and where it should be touched. Suppose here if you are plucking at this is it L by 2, and here it should be at L by 4 distance. This is at L by 4 distance, students. So at the point of plucking you will be getting as here antinode it's going to be forming. At the point of touching you will be getting as a node point you will be getting. So here plucked it will be at L by 4 distance, and touched will be at L by 2 distance. So that at the plucking point you will be getting as an antinode, at the touching point you will be getting as node point you will be getting. So node point will be from the fixed point at L by 2 distance, and the antinode point will be getting as L by 4, and the next antinode will be getting as 3L by 4 like that, and the node point will be here will be getting as L by 2 and L will be getting. So here the suitable answer will be plucked at L by 4 distance and touched will be at the L by 2 distance. Let us see the next question, students. The velocity of the waves in a string fixed at the both ends is given as 2 meters per second. The string forms a standing waves with the nodes of 5 centimeters apart. The frequency of the vibration of the string they are asking. So here it's given as, here the length of the string is given, students. The string forms standing waves with the nodes 5 centimeters apart. So here it's nothing but, here it's given as 5 centimeters apart it's given, and here it's going to be producing the standing waves, and this is the node point, and this will be the node point you can take. So L is nothing but, here you can get it as lambda by 2 you can take. Length is given as 5 centimeter, and here they are asking only the frequency L equals to 5 lambda by 2 and phi equal to, here you can take as lambda will be getting as 10 centimeters you are getting, and here you can take as V equal to, you can take as F lambda, you can take students here. The velocity is given as 2 meter per second, frequency we need to calculate, and here lambda will be getting as 10, and here we will be getting as, this is, so 5 centimeter is given students, you need to convert here, like lambda is 10 centimeter, 10 into 10 power minus 2 you can take, and here it becomes 10 power minus 1. So F value getting as 2 by 10 power minus 1 will be getting, it's nothing but 20 Hz will be getting. So 20 Hz is the correct answer. Let us see the next question, students. Standing waves are produced in a 10 meter long stretched string. If the string vibrates in 5 segments, and here it's a 10 meter wire it's given, and here its velocity is given as 20 meter per second, the frequencies. So frequency, the formula will be getting as, for number of segments you can take as F equal to PV by 2L you can take, students. And here a number of segments is nothing but P, it's given as 5 segments, and here with what velocity means 20 meter per second by 2 into total length is given as 10, and this 20 gets cancelled, frequency will be getting as 5 Hz you will be getting. Let us see the next question, students. 4 wires of identical length, diameters, and the same material are stretched on a sonometer wire it's given. If the ratios of their tensions is given as 1:4:9:16, the ratio of their fundamental frequencies they're asking. So fundamental frequency, the formula will be getting as F equals 1 by 2L into root over T by mu. Here tensions ratios is given as T1 is to T2 is to T3 is to T4, it's given as 1:4:9:16 it's given. They're asking the ratio of the fundamental frequencies. That means here you can take as F1 is to F2 is to F3 is to F4, which will be equivalent to, you can take as root T1 is to, so here it is related, F is directly proportional to root T, you can take root T1 is to root T2 is to root T3 is to, here you can take as root T4 you can take. So that's nothing but root 1 is to root 4 is to root 9 is to root 16 you can take, students. So here the fundamental frequencies ratios will be getting as 1:2, 2:3, 3:4 will be getting. So this is the correct answer. Let us see the next question, students. If you set up the 7th harmonic on a string fixed at both ends, how many nodes and how many antinodes are set up in it? 7th harmonic, students, 7th harmonic is nothing but number of harmonics, which is nothing but number of loops, students. Number of harmonics is nothing but number of loops you can take. So number of loops which will be equivalent to number of antinodes you can take. Number of antinodes. So number of antinodes, how many you will be getting? 7 you are going to be producing. So antinodes will be 7, and node points in the sense here will be getting as, let us take one example. Here this is a wire you are taking. If you are producing one segment here, this is a node point and node point, and this will be one antinode will be getting. So one segment it carries one antinode and 2 nodes will be getting. Like suppose here 7 harmonics when you are getting, 7 harmonics means, so number of node points will be getting as 7 plus 1 will be getting. So here for one segment or one loop 2 nodes, for 2 segments 3 nodes, for 4 segments 5 nodes, like for 7 segments you will be getting as 8 nodes will be getting, and the number of antinodes will be, which is 7 will be getting. So 8 and 7 is the correct answer. Let us see the next question, students. In order to double the frequency of fundamental note emitted by a stretched string, the length it is reduced to 3/4 of its original length, and the tension is changed. The factor by which tension is to be changes. And here the frequency, the formula will be getting as 1 by 2L into root over T by mu, students. And here you can take frequency which is directly proportional to, here you can take as root T by L you can take. And you just take here, they're asking here what the tension is changed, right? The factor by which tension is to be changes. Then you can take, students, here you can square on both sides. F square which will be directly proportional to, here you can take as T by L square you can take. T we required, it's nothing but here T is directly proportional to, you can take as F square into L square you can take, which is nothing but here you can take as T2 by T1, which you can take as F2 square by F1 square into, you can take as L2 square by L1 square you can take. F2 is given as already in order to double the frequency. That doesn't mean F2 equals, you can take as 2F1 you can take. And here this is 2F1 square by, here this is nothing but 4 will be getting 2F whole square, 4F1 square by F1 square into L2 is reduced to 3 by 4th of its length is given. So here you can take as 3 by 4 of L1 square, L1 by L1 you can take whole square you can take. F1 square gets cancelled, 4 into here L1 gets cancelled, 3 3 is 9 by 16 will be getting, 4 4s will be getting. So T2 equals to, here will be getting as T2 by T1, which will be equal to 9 by 4 will be getting. This is the correct answer. Let us see the next question, students. The tension of a stretched string is increased by 69%. 69% you are increasing the tension. In order to keep the frequency of vibration constant, its length must be increased by, and the frequency formula will be getting as F equals to 1 by 2L into root over T by mu, students. And length, how it is related to the tension and the strength. So just cross multiply this one. Here L is directly proportional to root T you can take. Other factors, so frequency here it is given as constant, it's given. F is given as constant. Then you can take L2 by L1, which is nothing but T2 by T1 you can take. So here it's nothing but L2 equals to, here you can get it as L1 into, you can take it as T2 by T1. So T2 you are going to be increasing 69%. T1 suppose you are taking as 100%, 100. T2 it becomes 169, students. So here you have to take, and this is L1 into, will be getting as 169 by, here will be getting as 100, and it's nothing but here will be getting as L2, which will be equal to L1 into, this is 13 by 10. It's nothing but here will be getting as 1.3 L1. Means initial length, suppose you are take as L2 equals to, here you can take as L1 plus, here you can take as 30% of L1. So it's a 1.31 and this is 0.3 times it will be an exceeding. In terms of percentage means 30% it's going to be increases. So here L2 value will be getting as, it's going to be increases by this 30%. Let us see the next question, students. Here a string in musical instrument is given as 50 centimeter long, and its fundamental frequency is given as 800 Hz, and then its frequency is given as 1000 Hz is to be produced. Then required length of the string they are asking. So here F equals to, you can take, students, 1 by 2L into, you can take as root over T by mu. Here F is inversely proportional to length you can take. Here you can take F1 by F2, or else you can take as L2 by L1, which you can take as F1 by F2 you can take. So here L2, which is nothing but here you can take as F1 by F2 into L1 you can take, students. Frequency it's given as 800 Hz is given, 800 by, it is 1000 into, you can take as L1 is given as 50. So here you can take, here 3 zeros, and here 3 zeros gets cancelled, 8 5 will be getting as 40 will be getting. So L2 value will be getting as 40 centimeter. Let us see the next question, students. Here are two uniform strings A and B of the made up of the steel is given or made to vibrate under the same tension if the first overtone of A is equal to the second overtone of the B, and if the radius of the A is given as twice that of the B, and the first overtone of A is equal to the second overtone of B, then the ratio of the lengths they are asking. So here you can take, students, first overtone is nothing but second harmonic of A, which will be equivalent to, right, if the first overtone of A is equal to the second overtone of the B. Second overtone is nothing but third harmonic, so it will be equivalent to third harmonic of B value. It's nothing but here you can write as F2. Here this is the second frequency which will be equal to the third frequency is given. Second frequency here it's given as, right, here you can write as second frequency is nothing but twice of its fundamental frequency. So here it's nothing but twice of its fundamental frequency of the A you can take, which will be equal to 3 times of its fundamental frequency you can take, which is for B you can take. So you know basic formula for fundamental frequency is F equals 1 by 2L into root over T by mu you can take, and here you can take 2 into, here you can get it as F in the sense 1 by 2 into, and here they are talking about length ratios, and it is going to be changed, so you can take it as 2 into length of the A into, and one more thing, students, here it's given as radius is given. Radius, if you are talking this sense, here you can write as F equals to 1 by 2L into, here even we can write it as mu, you can take it as mu, one more formula, you can write it as A into rho, you can take A into rho, it's 1 by 2L into, you can take it as root over T by A in the sense, here you can get it as pi r square into, you can get it as rho, you can take. So r square when you are taking outside, here F equals, here you can write as 1 by 2 into L into r will be getting by T by, you can write as pi into rho. So here L into r I am just taking length of the A into radius of the A you can take, into will be getting as T by pi into rho you can take, which will be equivalent to 3 times of 1 by 2 into length of the B into radius of the B into, you can take as T by pi into rho you can take. So same material wire in the sense density you can make it as constant, and here these are all gets cancelled, and here when you are simplifying, this side 2 and this side 2 gets cancelled, and here T by pi rho gets cancelled, and here we will be getting as length of the A by length of the B, which will be equal to 2 times of here 2 into RB by, you just cross multiply this one, students, 2 into RB by 3 into RA will be getting. So here 2 by 3, which will be 2 by 3 into RB by, here it is given as radius of the A is twice that of the B is given, twice that of the B is given, twice that of the B. So instead of RA I am just taking as twice that of the B is given, RB gets cancelled. So here this 2 also gets cancelled. So here LA by LB value will be getting as 1:3 or better. Let us see the next question, students. If the length of the string is shortened by 40%, so here it is shortened by 40% and tension is going to be increases by 44%, then the ratio of the final and initial fundamental frequencies they are asking. And here you can take, students, here the basic frequency formula F equals 1 by 2L into, you can take as root over T by mu. It's nothing but F is directly proportional to, here you can take as root over T by L you can take, and here you can take this is F dash by F, which will be equal to like T dash by T under root into, you can get it as L by L dash you can take. Here you just look at students, here it is given as, so tensional force is increases by 44% is given. So here you can take F dash by F is nothing but, right, first you can talk about the T dash values, T dash which will be equal to, so T plus here will be getting as 44% is increases means here you can take as 0.44 times you are increasing. It's nothing but you can take as T2 value you can take, or else directly initial tension you are take as 100, it becomes 44% means here it becomes T dash which will be equal to 144 times of the T1 you can take, T you can take, and here is the length is shortened by 40%. Length you are decreasing 40% doesn't mean here L dash remaining will be 60% will be there, 60 by 100 of the L, and here 2 3s are 2 5s will be getting, so L dash which will be equal to 3 by 5 of the L will be getting. We just put this value students, here F dash by F which will be equal to, T dash is nothing but it's 144 T by initial tension you can take as T, and L by final length value will be getting as 3 by 5 of L will be getting, LL gets cancelled, TT gets cancelled, F dash by F which is nothing but 144 under root is 12 12s, and here we will be getting as 5 by 3 will be getting. So when you are taking to the numerator, and 3 4s are 4 5s will, yes, here it will be in terms of T you can take 100 students, sorry, here you can take as 100, and here I forgot, and here we can take this is 12 by 10 you can take into, you will be getting as 5 by 3 you will be getting, so 5 2s and 2 3s are 6 6 2s will be getting, so here F dash by F which will be equal to 2:1 will be getting. So 2:1 is the correct answer. Let us see the next question students. The frequency of the transverse vibration in a stretched string is 200 Hz. If the tension is increased to 4 times and the length of the wire is reduced to 1/4 of its original value, the frequency of the vibration they are asking. So here the frequency formula will be getting as F equals 1 by 2L into root over T by mu. So here we just relate students, here they are talking about if the tension is increased 4 times and the length, and here F is directly proportional to, you can take as root T by L you can take, other you can make it as constant. That doesn't mean here F1 by F2 which will be equal to, you can take as F1 by F2 is nothing but L2 by L1 you can take into, you can take as root over T1 by T2 you can take under root. So here it's nothing but F1 by F2 which will be equal to L2. So length is reduced to 1/4 is given, it becomes L by 4 by L1 will be getting, L1 is nothing but L you can take, you just bring it to the denominator, and tension is increased to 4 times, this is T by, so second tension value will be getting as 4 times of the initial tension, so 4T you can take, TT gets cancelled, LL gets cancelled, then here F1 by F2 which will be equivalent to here 1 by 4 into, here you can take as 1 by 2, so here we'll be getting as F2 which will be equal to, will be getting as 8 times of F1 will be getting, initial fundamental frequency is given as 200 is given, so which is nothing but F2 value will be getting as 1600 Hz will be getting. Let us see the next question students. Here a string of length is given as 2 meter fixed at both ends. If the string vibrates in its fourth normal mode with the frequency of 500 Hz, then the waves would travels on it with a velocity of. So here they have given students already fourth normal mode it's given. So here fourth normal mode doesn't mean, so number of loops it's given as 4 it's given. So here you can take students f equals you'll be getting as for 4 segment, here you can take as 4v by 2l you can take, and here velocity they're asking, frequency is given as 500 which will be equal to 4 into v by 2 into length you can take as 2 meter you can take. So 2 2s are 4, 4 gets cancelled. Here velocity will be getting as 500 meter per second will be getting. Let us take the next question, students. The question says here, two vibrating strings of same material, means the density will be same you can take, but lengths are in the L and 2L and radii are given as 2R and R respectively. They are stretched under the same tensional force is given, same tension. Both the strings vibrate in their fundamental modes. The one of the length is given as L, which is with a frequency N1, and other frequency will be N2. The ratio of the N1 and N2 they are asking. So F equals here will be getting as 1 by 2L into root over T by mu you can take. And here in terms of here area when you are talking 2L into T by A into rho you can take. So instead of linear mass density you can take as A into rho also. A into rho is nothing but 1 by 2L into you can take as T by pi r square into rho you can take, students. And frequency here when you are talking, which is directly proportional to 1 by L. In denominator root r square will be there, you just bring outside, so here it becomes r will be getting. So then you can take the ratios f1 by f2 which will be equal to, it's nothing but L2 by L1 into you can take as R2 by R1 you can take. So here it is given as length ratios is given and here radius is given. L2 is nothing but you can take as 2L, initial length will be L and the radius will be 2R by R you can take. LL gets cancelled, RR gets cancelled. Sorry, here the first length is given as L. For that the radii will be getting as 2R will be getting. So here it is 2R and the R2 value will be R you can get. So here LL gets cancelled, RR gets cancelled, 2 gets cancelled. So here the frequencies ratios will be getting as 1:1 you are getting. Length, initial length radii is given as 2R and second length radii is given as R is given here. So here it's the ratio will be 1:1. Let us see the next question, students. Here the next question says, a string of length L is fixed at the both ends and vibrating in the second harmonic is given. The tension in the string is T and the linear mass density is given as mu is given. The ratio of the maximum velocity of the particle and magnitude of the maximum acceleration they are asking. So here velocity of the particle maximum by, here you can take as acceleration of the particle maximum, magnitude you can take. Velocity of the particle maximum is nothing but omega A or A omega you can take, and here you can take as A omega square. Omega gets cancelled, here will be getting as 1 by omega will be getting. And in terms of the propagation constant, in the sense here V equal to you can get it as omega by K, and here omega is nothing but here you can take as 1 by K into V you can take. So when you are taking this ratio here 1 by Kv is nothing but 1 by K, in the sense K is a propagation constant, it is 2 pi by lambda, and instead of 1 by K, in the sense here will be getting as lambda by 2 pi you can take, into here will be getting as velocity, in the sense root over T by mu. So when you are reversing this one, here will be getting as mu by T will be getting. So this is the velocity of the particle maxima by, here will be getting as here acceleration of the particle maximum formula will be getting, which is nothing but here you can take a string of length is given as L is given, and here both ends are vibrating in the second harmonic they are given. Second harmonic nothing but for second harmonic function L is nothing but right length, wavelength will be getting, Second harmonics doesn't mean here two segments it's going to be producing, and here length of the string is nothing but wavelength will be getting, and this is node point and node point you can take, right? And then here you have to substitute Vp maxima by, here will be getting as AP maxima, which will be equivalent to, this is lambda is nothing but here you can take as L, you can take L by 2 pi into L is given as right, L by 2 pi into, here you can take as mu by T, mu by you can take as T you can take, and when you are taking inside here you can take as 1 by 2 pi into L value, if you are taking inside it becomes the square value mu into L square by, here you can get it as T. So this is the correct answer, 1 by 2 pi into 1 by 2 pi into mu into L square by T. This is the correct answer. Let us see the next question, students. A wire has a linear mass density is given as 5 into 10 power minus 3 kg per meter, is stretched between the two rigid supports with a tension of, here it's given as 450 newtons. The wire resonates with the frequency 420 Hz. The next higher frequency at which the same wire resonates with the 490 Hz. Find the length of the wire they are asking. So for nth harmonic, if it is giving the 420 Hz, students, and for the next higher, in the sense here we can call it as n plus 1th harmonic you can take. For n plus 1th harmonic it is given as 490 Hz, it's given 490 Hz. Now we can take this ratio, students. Here 490 by, here you can get it as 420, which will be equivalent to, this is n plus 1 by, here you can take as n you can take, and here you can take 10 gets cancelled, 7 7 7 6 will be getting, we just cross multiply 7n, which will be equal to 6n plus 6 you can take, which is nothing but n equals to, here will be getting as 6 will be getting, or else here we are just calculating the number of segments, or else here you can take, this is P you can take, students. This is nothing but P plus 1 by, here this is P plus 1th harmonic and Pth harmonic you can take, this is a P, right? Here will be getting as number of segments will be getting as 6 will be getting. So frequency for 6 loops, in the sense here you can get it as F equal to, here you can take as 6 by 2L into root over T by mu you can take, and here this frequency here it is given 420, initially it's given as, the wire resonates at a frequency of 420 Hz is given initially. So here this is 420, which will be equivalent to 6 by 2L into, here you can take as T, in the sense tension you can take, it's given as 450 newtons by linear mass density, mass per unit length you can take, it is 5 into 10 power minus 3 per length is given as, the wire having a linear mass density 5 into 10 power minus 3 kg per meter is given, students. Already linear mass density is given 5 into 10 power minus 3. So n value when you are calculating 6230, so and here 3 140 times, and here it will be 5 90 times, and here when you are calculating this one, so this is 3 times, right? Here when you are calculating this length value, nearly will be getting as 2.1 meter you are getting. Let us see the next question, student. A steel wire of length is given as 1 meter and mass is given as 0.1 kg, and uniform cross sectional area is given as 10 power minus 6 meter square, is rigidly fixed at both ends. The temperature of the wire is lowered by 20 degrees Celsius. If the transverse waves are set up by plucking the string in the middle, calculate the frequency of the fundamental mode of the vibration. Alpha is given and Y is given. And F equals, here will be getting as 1 by 2L into, you can get it as root over T by mu. Right, here you are fixing between the two rigid support, a wire you are going to be fixing. and here temperature you are going to be lowering, then here thermal stress is going to be experienced by this wire. Then tensional force in terms of the this one will be getting as T equals to tensional force. Here it is directly I am giving the formula, students. Here you know the formula, else here you can take alpha equals will be getting as delta L by L into delta T, and here you can take as Y equals to, here will be getting as it's a thermal stress, here tensional force per unit area by delta L by L you can take. With this T by A you can get it as Y into delta L by L you can take, and T equal to, here will be getting as Y into A into delta L by L, and here Y into A into delta L by L is nothing but, here instead of delta L by L you can take as alpha into delta T you can take. So therefore frequency which will be equal to 1 by 2L into, instead of T you have to take as Y into A into alpha into delta T by, here you can take as linear mass density you have to take. F equals to 1 by length of the wire is given as 1 meter into Young's modulus is given as 2 into 10 power 11 meters into area is given as 10 power minus 6 into alpha is given as 1.21 into 10 power minus 5 into delta T. You are lowering 20 degrees Celsius by, you can take as linear mass density, mass per unit length 0.1 is the mass is given, and its length is given as 1 meter. 0.1 by 1 you can take as 1 you can take 0.1. So after simplifying all these things, here we will be getting as 11 Hz is the answer we will be getting, students. Let us see the next question. The next question says here a wave of frequency 100 Hz is sent along the string towards a fixed end, and here is a one fixed end is given, students. Here a wave you are going to be sending like this, and frequency is given as 100 Hz is string towards a fixed end. When this wave travels back, then after reflection a node is formed at a distance of 10 centimeter. The wave is traveling here, it's going to be producing one node, it's going to be producing. So at the receipt point we will be getting as a node, and here one more node it is going to be producing at a distance of 10 centimeter. So the speed of the incident wave they are asking. Here clearly we will be getting distance between the two nodes will be lambda by 2, which is known 10 centimeter we got, and with this here lambda you will be getting as 20 centimeter we will be getting. Therefore velocity formula will be getting as V equal to F into lambda, and frequency of the wave which is producing is 100 Hz is given, lambda equals to, you can take as 20 centimeter, which is nothing but 10 power minus 2 you can take. Here this 2 zeros and here 2 zeros gets cancelled, velocity equal to you will be getting as 20 meter per second will be getting. Let us see the next question, students. The ends of the stretched wire of length is given as L, and here are fixed at x equal to 0 and x equal to L is given. In one experiment the displacement of the wire is given as y1 equal to, here a sin pi x by L into sin omega t, with this energy is E1, and y2 is given as a sin 2 pi by L into x into sin 2 omega t, and here and energy is given as E2 is given, and here E1 which will be equal to, and here in the first equation y1 which will be equal to a sin it's pi x by L into, here it's given as sin omega t, and here its frequency you can take, students, as here initial angular frequency here it will be omega is given, so omega 1 equal to, you can take as omega, and y2 is given as a sin 2 pi x by L into, you can take as sin 2 omega t is given. So this final second angular frequency you can take as 2 omega you can take, and here energy relation in terms of the frequencies E equal to, here will be getting E is directly proportional to, you can take as a square into f square. Energy relation in a stretched strings will be getting E is directly proportional to a square f square you can take. It's nothing but here you can take as E2 by E1 which will be equal to a2 square by a1 square into E conductors, or else here we can relate omega also, students. Omega square you can take, omega also you can relate. Here you can take as omega 2 square by here you can take as omega 1 square you can take. Initial amplitude here A is given, and here also it's given as A is given. So here you can take as this is here A by A whole square you can take into here you can take as omega 2. Omega 2 is nothing but 2 omega. So it's a 2 omega by here initial one you can take as omega whole square you can take. A gets cancelled, omega gets cancelled. So E2 by E1 which will be equal to here will be getting as 4 will be getting. It's nothing but E2 equals will be getting as 4 times of E1 will be getting. Here this is E2 equals to 4 times of E1 is the correct answer. And basically the energy of the wave will be getting the formula, student. The E equal to here will be getting as it's a mu omega square into A square into L will be getting. With this here I am just relating E is directly proportional to A square omega square you can take. Now let us see the next question, students. The next question says here, a stretched string of length is given as 2 meter is found to vibrate in resonance with a tuning fork of frequency 420 Hz is given. The next higher frequency for which it resonates with the occurs is 490 Hz. The velocity of the transverse wave they are asking. So here for vibrating for nth harmonic, or else you can take for pth harmonic, the frequency you are getting as 420 Hz is given. And the next higher frequency in the sense here you can write it as P plus 1th harmonic you can take. For P plus 1th harmonic it's given as 490 Hz is given. And here which resonates with the occurs 490 Hz, the velocity of the transverse wave they are asking. You can take this ratio, students. Here 490 by here it is 420 Hz. This is for P plus 1th frequency by this is for pth segment. So when you are cross this 10 gets cancelled, and here you can take as 770 and here 760 will be getting, and you are cross multiplying. Here you can take as 7p which will be equal to 6p plus 6 will be getting, which is nothing but p equal to will be getting as 6 will be getting. So number of segments will be getting as 6 you are getting, students. Then here f equals to you can take as pv by 2l you can take, and frequency here will be getting as 420 Hz you can take, which will be equal to 6 into v by here 2 into length is given as 2 meter. So here you can take this is velocity which will be equal to 420 into 4 by 6 you can take. It is 70 times, and here 70 into 4 will be getting as 280 meter per second you are getting. Velocity will be 280 meter per second. And the next question says here, in order to increase the frequency of the transverse oscillations of a stretched wire by 50%, frequency of the transverse vibration you are increasing 50%, the tension must be increased by. And frequency the formula will be getting as 1 by 2L into root over T by mu you can take, students. Here frequency which is directly proportional to root T you can take. So with this here tensional force is directly proportional to F square you can take by squaring on both sides. Then you can take here increase in the tension is nothing but T2 minus T1 by T1 into 100, which is nothing but here you can take as F2 square minus F1 square by F1 square into 100 you can take. And here you are increasing 50%, doesn't mean F1 if you are taking as 100, F2 you can take as 50% increase means here you can take as 100 plus 50 you can get it as 150 you can take. And here you can get it as this is 150 whole square minus, and this is 100 whole square by F1 square is nothing but 100 square into you can take as 100 you can take. And when you are simplifying this one, here you can get it as 10 square if I am taking common in numerator by this is 100 square, and 100 gets cancelled, and this is 100 will be getting, and the remaining will be here 10 and 10 if you are taking common. Here 15 will be left over, 15 is 225 minus here will be 10 tensor will be getting as 100 will be getting. So 225 minus 100 will be getting as 125 percentage will be getting. So 125 percentage is the correct answer. So the next question says here 3 resonant frequencies of the string is given as 90, 50 and as well as 210 Hz is given. The highest possible fundamental frequency of the vibration of the string. So here you can take students fundamental frequency. It's a fundamental frequency must divide with the resonating frequencies. Must divide with resonant frequencies. So when you are taking here, it's a 90 Hz is given, 150 Hz is given, 210 Hz is given, and here 15 when you are taking 15 6er, 15 10er will be getting, and here it is not going. And here next one when you are talking 30 Hz if you are taking frequency, fundamental frequency 30 Hz if you are taking 31er, 35er and 7 times will be getting. So here exactly it's going to be cancelling. So like elimination method you can take students when you are taking 45 Hz and 60 Hz, here it is not going to be divided. So the thing will be fundamental frequency must divide with the resonating frequency. So the frequency, fundamental frequency is the correct answer will be 30 Hz. Let us see the next question students. Here the next question says a string fixed at both ends vibrating in the resonating length is given. In a resonating mode with the separation of 2 cm between the consecutive notes is given. Here for a next higher resonant frequency, the separation is reduced to 1.6 cm. It's given. The length of the string they are asking. So here, suppose here we don't know the length initially here for 2 cm long. Here how many segments we are producing we don't know students. Here we can take. These are the segments which you are going to be producing. You can take. And here this is n segments it is going to be producing. Then actual length of the wire here will be getting as L equals to you can take n segments when you are producing n into you can take as lambda by 2 will be getting, which is nothing but you can take as 2 times will be getting. So L is given as 2 centimeters. For the 2 centimeters here will be getting as n segments you are producing. So here you can take as 2n you can take. This is here you can take as n into 2 you can take, n into 2 you can take. And the next one it is given as for consecutive notes for the next higher resonant frequency. Next higher resonant frequency in the sense here will be getting as L equals to you can take as n plus 1 is the next higher resonant frequency, which is nothing but lambda by 2. So for these many segments here n plus 1 into lambda by 2 segments here its length is reduced by 1.6 centimeters. So here you can take as this is n plus 1 into this lambda by 2. It's given as n plus 1 into here you can take as 1.6 you can take. So here n into lambda by 2. Its lambda by 2 is nothing but here for n segments this length will be 2 centimeters given. So n times of its length you can take student, and here the next one for next higher frequency means n plus 1, and here it's reduced to 1.6 centimeters. This lambda by 2 it has been reduced as 1.6 centimeters. You just equate these two students here when you are equating. So 2n which will be equal to n plus 1 into you can take as 1.6 you can take. So when you are simplifying this one, so 2 here will be getting as 0.8 times. Here n equals to you can take as 0.8n plus here you can get as 0.8. And when you are simplifying this one here n minus 0.8n will be getting as 0.2n you can get, which will be equal to the 8. 0.8 you can get. N is nothing but here will be getting as 0.8 by 0.2. Here will be getting as 4 will be getting. So here 4 will be getting, then here you can substitute here L equals to the length of the string they are asking. So length of the string, which is nothing but here you can take as 2n you can take. So 2 into n value we calculated as 4, which is nothing but 8 centimeter you are getting. So here we don't know the actual length of the string, but here each segment it's given as this segment. Here it will be given as 2 centimeter initially. And the next here, when you are producing the n number of the loops, n plus 1 number of the loops, this is for n loops you can take. So each segment will be separated by 2 centimeter distance, and the next one here it is given as 1.6 centimeter. It has been reduced for n plus 1 loops. So here L value, length of the string we don't know, students. We are calculating the length of the string. L equals to 8 centimeter you are getting. Let us see the next question. A standing wave is produced on a string clamped at one end and free at the other end is given. The length of the string they are asking. And one side it is clamped is given, students. Here it is. Here at one end, in the sense here we are producing the node point. Here you can take clamped at one end and free and free at the other end it's given. It's a free at the other end, in the sense here we are going to be producing the antinode. And here again this antinode, again here it's going to be vibrating like this, and here again it's going to be producing, and again next antinode will be getting, and here again it will be producing the standing waves will be like this, and here will be getting as L equals to distance between node and antinode will be L equals to lambda by 4 will be getting. So just they are asking the length of the string will be antinode if it is forming at the free end side. At the same time here all the free ends when you are talking here you will be getting as it's an integral multiple of lambda by 4 will be getting. Right, here it will be 3 lambda by 4, and here the next node antinode at the free end will be 5 lambda by 4, like that will be getting. So it will be 1 lambda by 4, and here 3 times of its lambda by 4 and 5 times of its lambda by 4 it says, so that you can take as it's an lambda by 4 and 3 lambda by 4, and here it will be 5 lambda by 4, like 7 lambda by 4, like that will be getting. So it's a integral multiple of lambda by 4 will be getting. This is the correct answer. And let us see the next question. The length of the wire is given as shown in the figure. It's given between the pulley and the fixed support is given as 1.5 meter, and the mass is given as 12 grams is given. The frequency of the vibration with which the vibrates the 2 loops it's given, and here the middle point of the wire between the pulley at rest is given. Now here I just look at, students, here the length of the wire is given as 1.5 meter and mass is given as 18 kg. Mass is given as 12 grams is given. Okay, length of the wire and its mass is given. The frequency of the vibration with which the wire vibrates the 2 loops it's given. So here you can take, students, F equals to the formula for 2 loops, in the sense here we will be getting as F equals to, you can take as 2 by 2L into, you can take as root over T by mu you can take, and here 2 gets cancelled, it's nothing but 1 by L into, here we can take as root over T by, this is mass per unit length will be getting. When you are taking inside this length also, here it's nothing but T by, here you can get it as M into L square by L, you can take, LL gets cancelled. So here the frequency formula will be getting as T by, you can take as M into L, you can take, students. Tension is nothing but here T equals to, here you can take as 18G you can take. Tension can be supported by 18 times of the G, 18G you can take, and here you just substitute that value. So M, in the sense here will be getting as 18 into 10 by, mass is given as 12 grams, here you have to substitute 12 into, you can get as 10 power minus 3 into, you can get it as L value it's given as 1.5 meters is given. So when you are simplifying this one, frequency value will be getting as 100 Hz will be getting. 100 Hz is the correct answer. And let us see the next question, students. Three similar wires of frequency is given, N1, N2 and N3 are joined to make one wire. Its frequency they are asking. So frequency formula F equals here will be getting as 1 by 2L into, you can write as root over T by mu. So here frequency which is related to the length is 1 by L will be getting. That means here you can write as F into L, which will be equal to constant you can take. It's nothing but here in terms of N they are asking. So here also you can write as N you can take, or else frequency they have given the name as N is given and inversely proportional to N you can take. So N into L is constant means N1 L1 which will be equal to, you can take as N2 L2 which you can take as N3 L3 you can take, which is nothing but K you can take, students, some constant value. Total length is nothing but L equals L1 plus L2 plus L3 you are getting. L1 is nothing but here you can take as K by N1. L equal to here you can take as K by N1 plus here you can take as K by N2 plus here you can take as K by N3 you can take. So here L equals to here you can take as K by N you can take. So K you have to eliminate on both sides. So it's 1 by N which will be equal to, you can take as 1 by N1 plus 1 by N2 plus 1 by N3 you can take. So this is the correct answer. Let us see the next question, students. A stretched wire of length is given as 110 centimeter is divided into 3 segments whose frequencies are in the ratio 1:2:3. Their lengths must be in the ratio they are asking. That's nothing but here L1 plus L2 plus L3 which is given as 110 centimeter is given. Frequencies ratios is given as N1:N2:N3 you can take as 1:2:3. That's nothing but here if you are taking frequency, the relation F equals 1 by 2L into N equals 1 by 2L into root over T by mu you can take. N is inversely proportional to L you can take. That is nothing but N into L you can make as constant you can take. So here N1 L1 which you can take as N2 L2. When you are simplifying these two values, here N1 by N2 which you can take as L2 by L1 you can take, students, which is nothing but here will be getting as 1:2 ratio will be getting. So with this, when you are simplifying this one, L2 which will be equal to, here will be getting as L1 by 2 you are getting. So L2 which will be equal to N1 by L1 by 2 you will be getting. In the same way N1 by N3 when you are talking, here it will be in the ratio 1:3. It's nothing but you will be getting as L3 by L1 you will be getting. So with this, when you are simplifying, so here we will be getting as L3 which will be equal to L1 by 3 you will be getting. So now here we are bringing all the L2 and L3 values in terms of L1. Now you have to put these are all the values in the first equation. Therefore L1 plus L2 plus L3 which will be equal to here L1 plus L2 in the sense L1 by 2 plus L1 by 3 you can take, which is given as 110 centimeter. So when you are simplifying this one, here will be getting as L1 value you are getting as nearly 60 centimeter you are getting when you are simplifying. Then you have to put this value in the L2 value and you have to put this value in L3 value. So L1 equal to will be getting as 60 and L2 will be getting as 30 and here will be getting as L3 will be 20 centimeters you are getting. Let us see the next question, student. A string of length is given as L is given and here it is along x-axis, is fixed at the both ends and is vibrating in the second harmonic at a t equal to 0, y equal to, it's given as 2.5 millimeter it's given. For incident wave, the equation of the standing wave they are asking. And here you can take general equation you have to take, students. Here y equals to, here you can take as 2a sin kx into cos omega t you can take. This is a general equation of the standing wave you can take, students. And here at an amplitude is given as a string of length L along the x-axis fixed at the both ends and it's at t equal to 0, y equals is given as 2.5 millimeters is given. Means here its amplitude is given as already 2.5 millimeter. Its 2a value it's given as 2.5 millimeter it's given. And here you can take as K equals to, the formula will be getting as 2 pi by lambda, and here it is going to be vibrating when the second harmonic is given, student. Second harmonic in the sense, for second harmonic, here you can get it as lambda equals, will be getting as L will be getting. Second harmonic in the sense, two segments we are producing. For two segments here in the sense, here L is nothing but wavelength will be getting. Lambda equals, you can take as L you can take. And here V equals, the formula omega by K. And this with this here omega equals, you can take as V into K you can take, students. So here K is nothing but, here you can take as 2 pi by lambda into V in the sense, here you can take as velocity will be root over T by mu you can take. And this is the omega value we are getting, which is nothing but, here you can take as 2 pi into, here you can take as T by lambda you can take inside. Lambda when you are taking inside, here mu into lambda is nothing but L you are taking L. So here when you are taking inside, here lambda square is nothing but L square you can take. So this is the omega value we are getting. Now we just put all these values in the given equation. So here 2a is given as 2.5 millimeter, then amplitude will be getting as, this amplitude will be 5 millimeter you are getting. Therefore here y equals, here you can take as 5 millimeter into, you can take as sine K in the sense 2 pi by lambda. Lambda is nothing but, will be getting as L you are getting into X into, you can take as cos. So here you can take as 2 pi into omega, we got it as, so omega we got it as, so here you can take as T by, here will be getting as mu into L square you can take into T you can take, cos 2 pi into T. So here cos 2 pi into square root of this is cos 2 pi into T you can take. So this will be the correct answer. Sorry. Second one is the correct answer. Let us see the next question, students. Here a piano wire is given as 0.5 meter. 5 meter long it's given, and here its mass is given as 5 gram, is stretched by a tension of 400 newtons. The number of highest overtone that can be heard by the person is. So here the number of overtones, that doesn't mean, here you can take as human ear can hear, human ear can hear the highest frequencies 20 kilohertz, students. This is an audible range of the human being will be calling. And here for 20,000 hertz, so we don't know how many segments it is going to be producing. Here P segments if it is producing, and here you will be getting as, first we need to calculate the frequency, students. Here frequency, the formula will be getting as 1 by 2L into, you can take as root over T by mu. So here 1 by 2 into length is given as 0.5 meter into, here you can get it as root over T. Tension force is given as 400 Newton by, you can take as linear mass density in the sense mass per unit length. Here you can take as 5 into 10 power minus 3 by 0.5 you can get. And when you are simplifying this one, frequency you are getting as 200 Hz you will be getting. Sorry, frequency you are getting as 200 Hz you will be getting. So wire it is going to be vibrating with the frequency is 200 Hz. So how many segments it is producing we don't know. So here P into, here you can take as 200 frequency you can take. Then when you are simplifying this one, 200 into 100 times it is going. So P equals will be getting as 100 will be getting. 100 segment if it is producing in the sense, here the highest overtone they are asking. For P segments or P loops, for P segments, here P minus 1 overtones can be produced. photons can be produced. So P minus 1 is nothing but, here we will be getting as 100 minus 1, which is nothing but 99 is the correct answer. And the next question says the speed of the transverse wave in a stretched string is given as 700 centimeter per second. If the string is 2 meter long, the frequency with which it resonates in the fundamental mode they are asking. And fundamental frequency, the formula will be getting as F equals, so you can get it as 1 by 2L into root over T by mu, 1 by 2L into root over T by mu, or else you can take as, instead of this one you can take as V by 2L you can take. So here already the velocity is given, students, 700 centimeter per second. You have to convert 10 power minus 2 meter per second by 2 into length is given as 2 meter long is given. And here you can take 2 zeros gets cancelled, and here we will be getting a 7 by 4 hertz will be getting. Let us take the next question, students. Here it is given as a segment of wire, it's vibrating with a fundamental frequency of 450 Hz under a tension of 9 kg weight. Then the tension at which the fundamental frequency of the same wire becomes 900 Hz they are asking. So initial frequency is given as 450 Hz is given, and here the next frequency is given as 900 Hz is given, and T1 is given as, it's a 9 kilogram weight, and here they are asking the T2 value they are asking. And you know the relation between frequency and frequency relation is F equals 1 by 2L into root over T by mu, which is directly proportional to root T you can take. F is directly proportional to root T you are taking, and T is directly proportional to F square you can take, students, which is nothing but T2 by T1, which you can take as F2 square by F1 square you can take. So T2 equals to T1 into, you can take as F2 square by F1 square you can take. T1 is given as 9 kg, and here you can take as F1 square in the sense, here we will be getting as F2 square in the sense, here you can take as 900 by 450 whole square you can take. It's 2 times 2 2s are 4, will be getting 4 into 9 will be getting as 36 will be getting. T2 equals to, here will be getting as 36 kilogram weight will be getting. 36 kilogram weight. Let us see the next question. In an experiment, the string vibrates in 4 loops with 50 gram weight is placed in a pan of weight is given as 15 gram. To make the string vibrate with the 6 loops, the weight which has to be removed from the pan is approximately they are asking. So frequency, the formula you will be getting for P segments, the students, P by 2L into, you can get it as root over T by mu. So P by 2L into, here you can get it as T by, this is mass per unit length you can take, mass per unit length when you are taking, and here P and M when you are relating. So here you can get it as F is directly proportional to P by, here we will be getting as root M will be getting. So here when you are taking, to make the string vibrates, right, here you can take frequency also you can make it as constant, and here P is directly proportional to root M. So here you can take it as mass per unit length, here this is P by root M. Right, P by root M, here you can make it as constant, students. Here you can take it as 4 loops, 50 gram is placed on the gram weight. Here T is also it's given, and the weight students, here is placed in the pan of 15 grams, and here it is given as, here F equals to 1 by 2L into root over P by 2L into root over T by mu, and here you can take as string wire, it will be same you can take. Here linear mass density is constant alone, and here this is mu will be a constant value. Then it's a P by 2L into, here you can take as M into G you can take. So it's nothing but, here you can take as P into root M you can take as PM into root M you can take as constant, which is nothing but P is inversely proportional to root M you can take, and here you can take as P2 by P1, number of segments ratios I am taking, which will be equal to, you can take as m1 by m2, you can take under root. So here it's going to be suspended 50 gram weight, so tensional force is going to be varied, right? So here number of segments is given as final, it is given as 6 loops, it's given 6 by initial, it's given as 4 loops, which will be equivalent to m1, it's given as 50 gram weight is placed in the pan of weight 15 gram. So here total weight will be 65, you can take. By m2 we don't know, you just calculate some x value. By squaring on both sides, here we will be getting as 36 by 4 4 is 16, which will be equal to 65 by x will be getting. X is nothing but here this is m2, you can take, or else m2, right? So m2 is nothing but here we will be getting as nearly this is 65 into 16 by 36 will be getting, this value nearly will be getting as 29 grams will be getting, and weight will be removed as weight removed, which will be equal to, here you can take as 65 minus 29, you can take, students, which will be equivalent to 36 grams will be getting. 36 grams is the correct answer.